Looking for camera-related insights? You're certainly in the right place. Welcome back to another episode of Econ Systems Vision Vitals, your friendly neighborhood virtual space for all things embedded vision. All right, so what's today's topic? First, let's set the scene. You've got a multi-camera GMSL system running in a vehicle, a robot, or maybe a traffic hub. Now imagine one of those cameras gets unplugged, either intentionally for maintenance or just from vibration. In a traditional setup, that could crash the whole host system. Not ideal, right? Well, Econ Systems recently launched something called Steadicam 34, which uses a patented hot-pluggable GMSL system designed to handle exactly that. It's built to keep streaming stable even if a camera is disconnected. To unpack how this works and where it matters, we've got our embedded vision expert back with us. Glad you're here with us.
Hey, thanks. Yeah, this is a really interesting one. Hot plug capability in a SerDes link like GMSL isn't trivial. Getting it right means you can swap cameras on the fly without taking the whole system down, which is huge for uptime and safety.
Firstly, what does Econ Systems' patented Hot Plug and Play GMSL camera system actually do?
Right. Basically, it ensures that plugging or unplugging the camera, whether on purpose or from a micro-disconnection, won't crash your host. It prevents data corruption and electrical damage. The system uses a smart timeout mechanism. If the GMSL link drops, instead of crashing, it displays a proprietary frame to keep things stable. Once the link is restored, it smoothly reconfigures the camera and resumes streaming. That way, the host stays operational.
How does the system know if the camera is connected or not? There must be some continuous monitoring.
Exactly, there are a few polling mechanisms. First, you can pull the link lock register in the Serializer block via I2C. The host checks the register to see if the link is active or not. If the status changes, like if the camera's unplugged, the host can reinitialize or deinitialize the camera accordingly. Another way is polling a Serializer Register. The host sends a request over I2C. If it gets an ACK, the link's active. A NACK means it's disconnected. And then there's an interrupt-based method using a link lock output pin on the deserializer. That pin goes high when the serializer's connected, low when it's not. The change triggers an interrupt, so the host reacts immediately without constant polling. That's more efficient, with less I2C traffic and lower CPU use.
What about really brief disconnections, such as from vibration?
Yeah, good point. The system also detects micro-plugging or unplugging. These disconnections last just a split second due to things like vibration or loose connections. By catching these micro-events early, it prevents data corruption and instability down the line.
Does it do anything predictive? Like, can it foresee failures before they happen?
Yeah, actually. Apart from handling disconnections, the system analyzes connection patterns and data integrity to predict potential failures. That allows for proactive maintenance, which cuts downtime and boosts reliability. It's looking at the stability trends over time, monitoring signal quality, and even tracking things like error rates in the data stream. If something starts to drift or degrade, maybe because of a slowly failing cable or a connector wearing out, the system can flag it before it causes a full dropout. That kind of foresight is a big step forward for keeping vision systems, especially in remote or hard-to-service locations, running with much less unexpected downtime.
What about host processor compatibility and power protection?
It works with a variety of hosts. Even those without native I2C MIPI interfaces, they incorporate microcontrollers and USB controllers to ensure wide compatibility. And on the hardware side, There's protection against voltage spikes and power irregularities that can happen during hot plugging events.
And the software side? How does it manage CPU load?
Right, so polling frequencies are configurable. The system can reduce how often it polls when the connection is stable, which optimizes CPU usage without sacrificing responsiveness.
Where would this actually be used? Give us some real-world scenarios.
Sure. In automotive ADAS, think about long-haul trucks with multiple surround view cameras. During maintenance, you can hot swap a camera without powering down the whole system. That keeps critical safety systems online and reduces downtime. In industrial systems across factories and warehouses, vision systems guide robots and monitor production. This tech allows quick camera swaps or repositioning without stopping the whole line, which saves a lot of cost and hassle. For autonomous delivery robots navigating city streets, vibrations and jolts can cause momentary disconnects. The micro-plugging detection here ensures continuous operation, so the robot keeps navigating safely. And in smart traffic management, cameras are exposed to weather and physical knocks. Being able to hot swap a damaged unit without taking the network offline is a major advantage for continuous monitoring and traffic flow.
So it's really about robustness and uptime in dynamic, harsh, or safety-critical environments.
Exactly. It keeps multi-camera host systems running smoothly and safely, no matter what's happening around them.
Tell us about the actual product, Econ Systems Sturdicam 34.
Yeah, so Sturdicam 34 is Econ Systems' new 3-megapixel HDR GMSL2 camera. It's built with what they call the world's first 140 decibel HDR GMSL hot plug and hot unplug patented technology. Features include 140 decibel HDR, LED flicker mitigation, an IP-rated enclosure, and the ability to deliver clear images in tough lighting and environmental conditions.
That's a seriously rugged package. Thanks for walking us through how the hot plug system works, from the polling mechanisms and micro-plug detection right through to the predictive features and real-world use cases.
My pleasure. Yeah, it's a smart solution to a very real problem in connected vision systems. Being able to maintain stream stability and host uptime during camera swaps or disconnections, it genuinely changes how you can design and deploy systems in the field. Thanks for having me on to talk about it.
Really appreciate you laying it all out so clearly. Thanks so much for joining us today. We really appreciate your listening and spending time with Vision Vitals. To wrap up, we talked about Econ Systems' new patented Hot-Pluggable GMSL camera system, a technology that keeps multi-camera setups running smoothly, even if a camera is disconnected, thanks to smart polling, micro-plug detection, and predictive features. It's making a big difference in automotive, industrial, and robotics applications, where uptime and stability are critical. If you'd like to learn more about Sturdicam 34 or explore Hot-Pluggable GMSL solutions, visit Econ Systems' website or contact them at camerasolutions@econsystems.com. Thanks again for tuning in. We'll catch you in the next episode of Vision Vitals. Until then, stay safe, stay innovative.